A research team with 35 years' experience in ultrasound scanner design has developed a small, portable ultrasound scanner that interfaces easily with any personal computer. The demonstration here uses two experimental scanners built at Florida Atlantic University. This new design delivers performance superior to scanners presently on the market at a price point around $5,000, which is well below the cost of most competing systems. The scanner will provide wireless linking of the device to local displays, the host PC, and to the Internet for remote diagnostic consultation. Ultrasound scanners in the present market almost universally use phased arrays for scanning. These require complex processing of the signals from an array of 32 to 128 electrodes at a substantial disadvantage in both cost and performance. The mechanical scanner utilizes one small brushless motor and only has to process the output from a few electrodes, reducing the cost of the mechanical scanner to about 1/5 the cost of a comparable phased array. To reduce the number of individual electrodes, phased arrays are built relatively small, which means that they collect less of the reflected sound from a patient, and it also reduces their resolution and sensitivity. Mechanical scan can use a much larger transducer aperture to achieve much higher resolution and sensitivity. Phased arrays cannot get good resolution near the skin, so procedures that have been developed for these devices are primarily for longer range, large objects. They are well suited for obstetrics and for scanning the heart. For the heart, a small transducer has an advantage due to the small window between the ribs. For practically any other application, the mechanical scan offers considerable advantages. Phased arrays produce a pie-shaped scan, which must first be scan converted to be displayed on a computer screen which has a rectilinear display. They cannot achieve good resolution near the skin, and the useful information is in the far 2/3 of the image range. Visualized at right angles to the scan, it is only narrow at its farther range, and is progressively coarser at shorter ranges. In theory, phased arrays could match the resolution of mechanical scanning in both dimensions at all ranges, but this would require an array of about 10,000 electrodes and an equal number of processing circuits. The mechanical scanner also produces a pie-shaped scan, but the scan is converted into a rectilinear shape by a lens at the skin's surface. No electronic processing is required to convert the reflected image on a computer, and the transmit and receive beams are in focus within the same variable range. This greatly improves the resolution and sensitivity at that range. As with conventional photographic lenses, a very fast lens used in ultrasound has a short depth of focus, so we find it useful to adjust this transmit focus on the object of greatest interest. A simple digital variable focus method was developed for the transducer. For this prototype, circuitry was developed to drive the scanning head and process its output for display on a PC. The experimental prototype shown is a fixed focus scanner with good resolution at its focal range and minimal geometric distortion. Here is a carotid artery scan made with the experimental prototype. The resolution is about 0.5 millimeter in azimuth and about 1/3 of a millimeter in range. An experimental wireless prototype is shown here. The new production prototype will include wireless communication between the scanner and the host computer. In a production version, the same function can be achieved in a smaller package with highly integrated circuit devices. This scanner would look like the scanner shown here. This design would be battery-powered and small enough to fit into a physician's pocket. Based on the demonstrated experimental prototype, and including the variable focus feature, the next generation scanner would be lightweight, consume minimal power, and have good resolution at all ranges. A concept drawing of this future design is shown in cross-section to reveal the placement of components within the scanner. The new design will be ideal for screening during a physical exam by a physician. It is well suited for scanning the breast, the carotid artery, thyroid, and many other areas that are within 4 centimeters of the skin. Problems discovered during the screening can be referred for a biopsy or other more detailed study.